calculator, you can take a look at it that way, see if it passes the vertical line test. So what is this an equation of? A circle. Is that a function? No. This guy, we could say yes, because every y, if whatever x I put in here, 1 and negative 1, it's okay for 1 and negative 1 to have the same y, but every x I put in there only gets one y. And put it in your calculator. It's a good one to put in your calc. This is an equation of what? A line. So a line is a function unless it is a vertical line. So then it's okay. And then it is not a function. Here's a problem here. When we take the square root, remember, when you take the square root and you physically undo this, you get a plus or minus. That means for any x that you plug in, and just make yourself a little table like this. For any x you plug in, if x is 1, 1 minus 1 is 0, so 0 works. If x is 2, 2 squared is 4, minus 1 is radical 3, but it gets a plus and a minus. So it's going to give you two y's there to your 2. You're going to get a negative radical 3, and you're going to get a positive radical 3. This makes it not a function. Everybody okay with these? Yes.
So how come 19 is under the radical?
It is because we didn't have to, it's the y that you're looking at. We didn't have to take the square root of y. And so if I put an x in here, if x is 0, 1, 2, if I put a 0, well, I can't use a 0. If I put a 1, I get a 0. If I put a 2, I get a 1. The radical is already there, so it's going to be a positive. When we undo it, we get a positive and a negative.
I solved for y when I put that in the equation. It was when I put the vertical line, it was past.
Because you have to put in both, the positive and the negative. When you undo your square, you have to put in the positive and the negative. So technically, in your y1, you have to put in the positive, which will give you this piece. Then you put your y2, you have to put in the negative of this. And that'll give you that piece. That's how you graph your circle. Because when you undo a square, you get a positive and a negative root. Normally, if the square root is there, like this one, then this is understood to be a positive, right? It comes out and has to be the positive. Sometimes they will put a negative in front of it, and then it's understood they want the negative only. But you still only get one root with this. When you undo it, you get two roots, a positive and a negative. That might be one of those little habits that we have to keep thinking about, because if you do it over time and you forget to do the positive and negative, when you undo it, it's hard to undo that in your mind. So you got to keep thinking about that. Absolute value, yep, it has a little transformation, but that's okay. It's still a function. Every x that I put in will only give me one y. This is a vertical line. X equals -7. Vertical line is not a function. That one x has all those different y's. That's not a function. A little function notation. Everybody okay with this? So we plugged in the -4 into t, and then we plugged in the t plus 2 into t. Same as you just plugged in the -4. This gives you an expression, because it contains a t. This is kind of designed to help you when you do the difference quotient, when you're plugging in that other little piece in there. Kind of gets you thinking on the same path. Well, if I can plug a -4 in here, I can plug a 10 in here, I can plug an x in there, I can plug an x plus 2 in there, I can plug a t plus 2 in there. It's just substitution. This one has two places, two t's. So I'm plugging the 1.5 into both of those t's. Then I'm plugging an x plus 2 into both of those t's. Make sense? It's just substitution. And when you get to this point, this should help you when you get to your difference quotient, because that's exactly what you're usually plugging in. Something that has two terms. And one other thing, don't leave this to me like this. This has to get resolved. For those of you that have Mr. DiCaprio last year, I think he calls this sloppy. He says that to his algebra 1 kids. This is sloppy. You need to resolve your parentheses, collect your like terms, and give me one good answer. Again, just a matter of substituting in. Substitute in the 0.25, then substitute in the 4x squared. You could resolve this if you like. What does this become? 2x. You can leave it like that. I think the goal was just to get you substituting. You could resolve this one. 0.5. This one you probably could resolve the whole way through. This time we put the x in your denominator. I'm sorry? Did yours say something different? Yours has a 2?
No, it's a 0.
Oh, I probably just misprinted this. I just probably did a typo. So you're plugging in the 2. Does this have a domain restriction?
Yeah.
Mm-hmm. What values of x can I not use? 3 and negative 3. This cannot be a 0, right? So if I set this equal to 0, I know it didn't tell you that, but whenever we can, we'll throw in domains. This way, the more you work with them, the better off it gets. So this says I cannot use, see, I'm undoing my square. I get a positive and negative 3. That's the numbers you cannot use. But your restricted domain is all the numbers without these guys. So negative infinity to negative 3. Make a number line if it's helpful. Take this out, take this out. Jump over the negative 3. Don't forget this middle part. From negative 3 to 3. Then this part from 3 to infinity. So those are two numbers we cannot use. Y plus 3, we can substitute into y plus 3. Make sure you collect your like terms. This domain, I don't have the directions. What did I ask you about this one? Define the domains? Domains. This guy has no restriction. There's no fraction. There's no radical. Plug it in your calc. It's a nice little parabola. I can put in any x. Look at your table. There is no error there for any x. This one has a fraction, so t cannot be equal to 0. Take the 0 out of your real numbers, and what's left is everything but the 0. I'm going to keep throwing domains at you until everybody's light bulb goes on and says, that's all there is to a domain. 3 restrictions, and that's it. Just 3. Again, if you have an odd root, an odd index, you have no domain restriction. 61, you have 2 denominators. Neither one of them can be 0. So x cannot be 0 and negative 2 cannot be 0. Remove them from your real numbers. A domain is different than a solution. A domain is what we start with. And we say, what can we use to look for my solution? Number 63 gives us the radical under in a denominator, which means my radical cannot contain a negative, and because it's in the denominator, it cannot be 0. So I just set it greater than 0. With your domain as interval notation. Good. Questions up to here? Everybody's catching the domain part? Okay, difference quotient. How did this go? Okay, so let's go throw it together in case you didn't catch this. Again, start like this. This is the x. This is an x. This is where my x is. All it is just a series of substitutions. So for the first time, we're substituting x plus c. So we rewrite this function with x plus c. That's it. There's nothing else to that function. Then we're going to do this part. This one. It just says give me an x. So I plug an x in for x, which is already there. That's all I have to do. And they had a c. Our goal is to eliminate that denominator. In this case, a c. It just shows you can use any letter in there. Eventually, you'll be using just the h's in there. But the concept works for anything. So I distribute. I combine my like terms. Anything without a c, in this case, has to get eliminated. Because you have to be able to factor out a c. If this didn't, I would go back and look and see what did I do wrong. So now I'm left with 2c over c. And now I can take out my c. You cannot cancel terms. You can only cancel factors, not terms. Okay? It's a little tough to catch this in the beginning, and I have a cute little worksheet that might help you get into the composition part of it. But eventually, like if you do this, this really kind of helps. Put the x up here, and in your function, wherever there's an x, substitute that in. Okay. Do you want to cross that? That's not x. You sure? Okay. All right, and again, messy as it is, let's just do this part. This is an x, so let's do this piece first. This says, wherever I see an x, substitute this in. This is exactly what you did on the homework problems above this. We substituted in a 2, then we substituted in an x plus 2, or an x plus c, whatever we substituted in. Substitute this into the both x's. So I rewrite this. 2 plus h, I have a square, minus, don't forget your parentheses, 2 plus h. 9 times out of 10, if something doesn't reduce, it's because of this minus sign. Okay, and don't forget this plus 1. This is part of your function. Now, keep this minus sign. Here's the second part. Put a 2 into the x. But don't forget to keep the minus sign. So I've got a 2 squared minus 2 plus 1. That part you can even do right in your calculator. Just right in here. This has to get distributed out. You can't just do 4 plus h squared. This is a binomial. You have to do this. So you get 4 plus 2h plus 2h plus h squared. Distribute your negative. Plus 1. Don't forget your 1. And take all of this. 4 minus 2 is 2 plus 1 is 3. Wait so far? Right, now collect your like terms. I see an h squared. I see a 4. Minus 2 is 2. Plus 1 is 3. Minus 3. All gone. And I see h squared. Let's put them in descending order. And a 4h and a minus 1h gives me a 3h. At this point, whatever's left has to contain an h, or whatever your denominator is. Factor out the h, and then take out your factor. Okay? Questions at all? This is usually a little difficult to get it started, but once you get the hang of it, All it is substitution. It's just function notation, putting it in a weird way. -3, we took this, we substituted the 2 into here. So 2 squared minus 2 plus 1 gave me 3. And this was a subtract. Don't forget to do the second part. So sometimes it's easier to go like this because it kind of reminds you I have to do it once, I have to do it for the second part. Questions? You guys that were in here yesterday?